Hi, I'm Luis, and this is my video explaining the exercise. I'll start with the sketch that I drew by myself. That is the person with the platform, and then is the person without the platform maintaining the equilibrium in the wall of the cylinder. We are assuming that the radius of that cylinder is 3 meters long, and the time to complete a turn is 1.6 seconds. The known data is the time, the radius, the mass, and the gravity. Then the unknowns are the angular speed and the coefficient of friction. I chose the coefficient of friction because all back in 561 I remember that I only saw one exercise that involved the coefficient of friction as an unknown. So that's the reason I choose them. Well, this is the diagram, the free body diagram. Well, as we see here, the the person is having a weight going downwards here because the platform isn't there, and there's a friction upwards because there are centripetal force that push the person upwards. That is the reason the person doesn't fall. This is the centripetal force make the person doesn't fall and stay in equilibrium in the wall. Now we are going through the solution. Well, to obtain the angular speed, we are using a formula, and that is formula. And substitute, we got that angular speed is 2 pi divided by 1.6. Remember that 1.6 is the time and 2 pi is the period. Is the period in radians. And that division result that the angular speed is 3.92 rads per second. Then we move to B. That is how we obtain the coefficient of friction. Well, first of all, we have to know that the weight is the mass by the gravity, and the centripetal force, the centripetal acceleration is angular speed square by radius. And to find the centripetal acceleration, we know the angular speed already, so is 3.82 square by 3. That is the radius of the cylinder, and we obtain that the centripetal acceleration is 46.09 meters per second square. Okay. Then we go through this friction force. That is a coefficient of friction by normal force. As we see in this problem, the normal force is the centripetal acceleration because that is the reason the person doesn't fall. Well, we go through here that the normal force is the same as the centripetal acceleration. Then in the summatory of forces in y-axis, we got that F, that is the friction, minus the weight is equal to 0 because the object is in equilibrium. Then we the, we leave alone friction, and that way then we can transform friction here, that is the coefficient of friction, by the normal force equal the weight. Then we do we The normal force is the centripetal acceleration pulled by the mass, okay? Because that's the normal force. Okay, now we eliminate the mass because we by algebra we know that it's 1, and then we obtain the coefficient of friction. That's the coefficient of friction is equal to the gravity divided by the centripetal acceleration, that is 9.81 divided by 46.09 meters per second square. That we obtain that it's mu. The coefficient of friction is 0.212. Thanks.